So a couple bonus problems for us from section 10.3. The first thing we have to do is we have to check to see if this is an equation that's quadratic in form. It's quadratic in form if this exponent is half of this one. So 2/3 times 1/2, well, those cancel, gives me with 1/3. So half of this gives me this. So it's quadratic in form, that checks. When it's quadratic in form, we're going to make a little u substitution. You're going to let u equal the middle variable part. Nothing to do with the coefficient, just the variable. So it's going to be u equals x to the 1/3. Now if I square both sides of this, well, I'll get u squared. And squaring this is going to be multiplying the exponent by 2. I'll get x to the 2/3. So that gives me a convenient substitution for everything I have up here. This is my u squared minus 7u plus 12 equals 0. And that's something that'll factor. How'd that factor? Thank you. U minus 4 and u minus 3. Now this part is just to get us past working with something that has fractional exponents. So I get u equals 4 or u equals 3. Those are my two solutions here. But my original problem was not to solve something in terms of u. It's to solve something in terms of x. So let's go back and solve in terms of x. U was a stand-in for x to the 1/3. So let me go back and work in x's. That's x to the 1/3 equals 4, or x to the 1/3 equals 3. Now my suggestion to you earlier was this. When you get down to here to solve, you're going to raise both sides to the reciprocal power of the exponent. So that's x to the 1/3. What's the reciprocal of 1/3? So I'm going to cube both sides. So 3 times 1/3, that gives me x to the first power, or just x, equals 64. Now likewise, you can do things here. You can cube both sides here. Works the same. But let me give you a different look at this. Something to the 1/3 power. Do you remember how to write that with radicals? Yeah. The 3 comes over, the 1 drops down. I get the cube root of x. And to solve here, well, what undoes a cube root? What's the opposite of a cube root? Cube both sides, right? Which is what we did over here. So if you cube both sides here and here, we end up with another solution. X is 27. So you got those two solutions. How come I didn't need the plus or minus? Yeah, because the numerator of this exponent is odd. If that numerator was even, if that was a 2 up there or a 4, then I'd need the plus or minus. But because it's odd, I don't need to worry about the plus or minus there. Nice. Let's do one last one, and then we'll take a well-deserved break. Anything else on this one before we do our last one for this section? Looking good there? No one wants to slow down the progress. Like, no. Let's get us on break. Okay. So let's take a look at x to the 4/3 minus 10 x to the 2/3 plus 9 equals 0. First things first, is this quadratic in form? Yeah. 4/3 times 1/2 gives me 2/3 because the 2's will cancel. So yes, it is quadratic in form. You can make a u substitution here. So let's solve this by making our little substitution. I'll give you a moment to figure out what u should equal, and then u squared. And then we're going to substitute. Sean, what should I let u equal in this particular case? Perfect. X to the 2/3, and that makes u squared x to the 4/3. Awesome. Chris, with these substitutions, what can I rewrite my equation as? Good. Except let's use u's instead of x's. Yes. So u squared minus 10u plus 9 equals 0. How does that factor? We need two numbers that multiply to 9 and add to negative 10. Both have to be negative. Somebody said it. Thank you. 9 and 1. Perfect. U equals 9 and u equals 1. But we're not going to stop here because we want to solve this problem in x, not in u. So we need to keep going. And you're right. Thank you. Let's go back to, well, u was really taking the place of x to the 2/3. So it's x to the 2/3 equals 9, or x to the 2/3 equals 1. Ah, yeah. So let's take a look at two things here. Let's remind ourselves. So the idea is to raise both sides to the reciprocal power. So what's the reciprocal of 2/3? 3/2. Good. And if the numerator of the exponent is even, then we need to use a plus or minus. So am I going to be using the plus or minus in my solution here? Yes. So we got both of those things working for us. Let's run through this. That's going to be x to the 2/3 raised to the 3/2 equals plus or minus 9 to the 3/2. Likewise, over here, x to the 2/3 raised to the 3/2 equals plus or minus 1 to the 3/2. Now I'll be really helpful here. On the left-hand side, you just get x, which is cool. And I'll tell you what, we'll do that over here. We also get x. But let's figure out what that equals on the right-hand side. And this one should be contrived to work out pretty nice. So it's going to be plus or minus. Can you turn that into a radical for me? What would it be? Remember how that works? The 2 comes over, the 3 drops down. Square root of 9 cubed, right? Now when you do these, let's make our life easier on ourselves. Let's do the square root part first. What's the square root of 9? 3. Plus or minus 3, but I didn't use the cube. What's 3 cubed? 27. Yay. And then over here, 1 to any power is just 1, so I'll get plus or minus 1 for my other two solutions. So, yay. Not bad. You get all 4 of those on a test, I'll be really, really happy. That'll make 2 of us, I'd be really, really happy. So, any other thoughts on this last one here? Awesome. I think you guys earned yourself a break. I'll see you at 10 after.